everyone, this is Ms. Mazzone, and today we're going to be talking about adding fractions. We're going to be adding with the same denominator and different denominators, just so you're aware. Also, if you're a lower level student or parent, I do have some variables later on, so just so you're aware about that, okay? Alright, so we're going to start with the same denominator. If I have the fraction 2/5, that really means I have 2 out of 5 pieces in this pie. I'm going to add that to 1/5, 1 piece out of 5. So if I take those and put them together, I have 2/5, 1, 2, plus 1 more fifth gives me how many fifths? 3/5. So if you notice, when we add fractions, the denominators are the same because they stay the same. I still have the same number of pieces, I'm adding together the number that I care about. The number of pieces in our pie did not change. So take a second, what do you think this one is? 2 out of 7 plus 3 out of 7. So we have our 2/7, 1, 2, and our 3/7. 1, 2, 3. So how many sevenths got filled in this pizza pie? Out of 7 pieces, it's still 7 pieces. We're just adding together the shaded pieces. 5 out of 7. The number of pieces gets added together, but the number of total pie pieces in the whole pie is the same. Alright, so pause the video, see if you can do any of these problems. So the first one is very basic. Again, our denominator is the same. All we have to do is add our numerators together. 10 plus 3 is 13. Done. Now number 4, pay attention, because that's not adding. That's a subtraction. So this time, we're going to subtract our pieces. 13 minus 5 is 8, but we still have a total of 21 pieces in our total pie. Our whole is still 21, even though we're taking away pieces. Now number 5 is a little trickier, especially if you have these variables. Again, notice the bottoms are the same though, they're both x. When we add fractions, our denominator stays the same. We have x total pieces, and 9 of them plus 5 of them is 14. That's your answer. Similarly, I have 25 total pieces in my pie. That's not going to change. I'm adding 2x of them plus 9x of them, which gives you 11x of them. So that's it. When we add or subtract, the denominator stays the same. We add our numerators or subtract if we're subtracting. Okay? The bottom does not change. It represents the total in that pizza pie or that whatever fractional thing that you have. Maybe it's students in a class. The number of students in the class doesn't change, even though I'm focusing on like all the girls over there, or the boys over there, or everyone together. Alright, so now what we're going to do is we're going to look at what if the denominators are different. So I want to add a half plus a third. A half plus a third. So I'm going to draw that. So I have my half, which is over here. And then I have my 1/3. So that looks like this. But I want to break this up. I don't know what amount of the circle this is. So what we're going to do, I'm going to take my half and I kind of want to turn it into something that looks like that. So what we're going to do is we're going to draw that. But still, it's hard to tell. Notice this is like 1/3 of a half. So what we're going to do is we're going to turn this into that. How many pieces total are there now? 1, 2, 3, 4, 5, 6. There's 6 pieces. How many of them are filled in? 1, 2, 3, 4, 5. So what we need to do when we add fractions with different denominators, we need to find a common denominator. In this case, it was 6. We needed to turn 1/2 into 6. To turn 1/2 into 6, how do you turn 2 into 6? What do? You multiply it by 3 times 3 times 3. 3 times 2 is 6. 3 times 1 is 6. Each of my halves was being cut into thirds. Each of my halves was being cut into thirds. But I also need to turn this into sixths. How do you turn 3 into a 6? Well, 3 times what number is 6? Times 2. Whatever you do to the bottom of a fraction, we do to the top of a fraction. 3 times 2 is 6. 2 times 1 is 2. So we ended up with our 6 on the bottom, and then 3 plus 2 is 5. So what I'm doing to this fraction, each piece is being cut in half to turn these into sixths. So that's what the basic idea. We'll go through the process a little bit more. So when the denominator of fractions are different, you need to find a common denominator. And this is only the case when adding and subtracting. Multiplying and dividing are very different. They're actually easier. This is only when you are adding and subtracting do you need a common denominator. A lot of students get so into it that when they're multiplying and dividing later, they try to find a common denominator. Nope. You only need the pieces to be, the number of pieces total to be the same if you're adding together. Alright, so 2 out of 5 plus 4 out of 5. We need a common denominator. How can we turn those into the same amount? So if I have a fourth, I have fourths, somehow I need to make fifths also. So one way of doing that is I'm going to turn each of the fourths into 5 pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now how many pieces are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What did I do to get 20? We just multiply those two together. That always works. It's not always the easiest method, but it always works to just multiply your denominators, and that's your new denominator, right? We can't add these because those are different. We don't know what those two fractions represent. So, we need to turn 5 into 20. What do you multiply 5 by to turn it into 20? Times 4. Whatever you do to the bottom of a fraction, you have to do to the top. You can't just magically change it. No math magic. 4 times 2 is 8. So that's my new numerator. On the other side, what do you multiply 4 by to turn it into 20? Times 5 times 5. Whatever you do to the bottom, you do to the top. 4 times 5 is 20. 1 times 5 is 5. Now you're able to add across. The bottoms are the same. 13 over 20. So we had 2 fifths. So like we had the 1/4, right? Our 1/4 ended up being 5 of them, and then 2/5 was another 8. 5, 6, 7, 8. And that represented our 2 fractions being added. Okay. All right, now this one's a little different. 2/3 plus 1/9. We need our common denominator. So how are we going to do this? So if I start with the 2/3, right? So I have thirds. There's my thirds. Somehow I need ninths in here. Is there an easy way to turn these thirds into ninths? Well, if I do this, if I turn each of those into thirds, I now have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the common denominator is 9. And good rule of thumb, before you do anything, does the smaller number divide evenly into the bigger number? If it does, the bigger number is your common denominator. So always check, can my smaller number be turned into my bigger number? In this case, it's a yes. So how do I turn 3 into 9? Multiply by 3. 3 times 3 is 9. Multiply on the top, same number. 3 times 2 is 6. What do I do to turn 9 into 9? It's already there, right? Do we have to do anything? No. Now some students write times 1 times 1. That's nice, that's showing you understand the process, but it's the same number, it's not changing. Leave it as a 1. That fraction didn't need to change. Now we can add across. Our denominator is 9, our numerator is 7. Alright, so take a minute, go through, and at the very start, just think about your new denominators. What are your new common denominators? Alright, so for this first one, we have 5 and 7. These are both prime, so again, just multiply them together. If you didn't do that part, take a pause of the video and find your new numerators. What do we multiply 5 by to turn it into 35? Well, we multiplied it by the 7. So times 7, whatever we do on the bottom, we do on top. 7 times 2 is 14. Now the bottom. How do I turn, or the right one, how do I turn 7 into 5? I multiplied it by 5. Times 5 times 5. 3 times 5 is 15. Now that my denominators are the same, I'm allowed to add them. 14 and 15 is 29. And we are finished. Next one. 3 over 8 and 1 over 2. So does 2 go into 8? It does. Since 2 goes into 8, 8 is my common denominator. So this is a nice one because the 3 over 8 isn't going to change. It's already an 8. How do I turn 2 into 8? Times 4 times 4. 1 times 4 is 4. Add across. 1 over 10 plus 2 over 3. Does 3 go into 10? It doesn't. So what number, do we just multiply them or is there a smaller number? No, for these we're just going to multiply. 3 times 10 is 30. Times 3 times 3 times 10 times 10. So we get 23 out of 30. This next one's a little tricky. Does 12 go into 18? It doesn't. However, Multiplying those two together would be horrifying. Those would be very big numbers. So there's a bunch of ways to figure this out, but you want to figure out what number do those both go into. One method is taking your bigger number and finding all its factors. So we have 18. Okay, this marker's turning fast. Let's try green. So we have 18. It's 18 doubled. 36 times 3. Is that 54? 72. And so throw up a few of them, and then look, which one does 12 go into? 12 doesn't go into 18, does it go into 36? It does. So our common denominator is going to be 36. There are multiple options. You could have even used 72, because 12 goes into 72. You could have just multiplied them, but I don't want to do that much work. It'll make the numbers really big, and it gets frustrating. So my common denominator is 36. What do we do to turn 12 into 36? Times 3. Whatever we do to the bottom, we do to the top. So we get 15 over 36. What do we do to turn 18 into 36? Times 2 times 2. 7 times 2 is 14. Sorry, we're going to have space down here, so it looks awkward. Now that the bottoms are both 36, we can add our numerators. 15 and 14 is 29. So that's adding fractions with different denominators. Good. Hope this was helpful. Have a great day.